There is an equation that should have changed everything. When Frank Drake wrote it on a blackboard in the autumn of 1961, in a small conference room in Green Bank, West Virginia, the scientists gathered around him didn't react with gasps or silence. They reacted the way scientists usually react to something deceptively simple. They leaned forward, slightly, the way you lean toward a flame that is just a little too close. The equation was elegant, in the way only truly dangerous things are elegant. It asked a question that seemed purely mathematical, purely astronomical, purely about probability and stellar formation rates. It did not feel in that room like a question about the fate of every civilization that has ever existed. It did not feel like a mirror, but that is exactly what it was. The Drake equation does not calculate the number of alien civilizations in the universe. That is a common misunderstanding, and it matters that you understand why. What it does is something far more unsettling. It maps the shape of our ignorance. It takes everything we don't know about the emergence of life, intelligence, and technology, and forces us to confront those unknowns as multiplication factors in a single formula. Every variable that approaches zero becomes an existential verdict. Every variable that holds steady becomes, paradoxically, a reason to be more afraid of the silence, not less. Because here is what that equation tells you when you plug in the most conservative estimates. The cosmos should be teeming with voices. And here is what we hear. After more than 6 decades of listening. Nothing, not faint signals waiting to be deciphered, not ambiguous static that might be something, nothing that holds up, nothing that repeats, nothing that points back at us and says, "We are here too." The sky, which contains more stars than there are grains of sand on every beach and desert on Earth, which contains more planets in habitable zones than there are human beings who have ever lived, is, by every instrument we have ever built, profoundly, completely, almost offensively silent. This silence has a name. Scientists call it the Fermi paradox, after the physicist Enrico Fermi, who reportedly asked the question at a lunch table in 1950 with the kind of casual precision that only the truly brilliant can manage. Where is everybody? 3 words. And in those 3 words, perhaps the most destabilizing question in all of human intellectual history. Not destabilizing because it suggests we are alone, though that possibility is staggering enough. Destabilizing because the alternative, that we are not alone, that the universe is full of minds, and that those minds are simply not communicating with us, implies something about the structure of reality that we are only beginning to have the language to describe. You have probably heard the standard answers. Maybe intelligent life is rare. Maybe the distances are too vast for signals to cross. Maybe civilizations destroy themselves before they can transmit for long. Maybe we are looking for the wrong kind of signal. These explanations have circulated for decades in popular science, in documentaries, in late-night conversations between people who find the scale of the universe genuinely vertiginous. They are not wrong, but they are incomplete in a way that matters more today than it did when Fermi first asked his question. Because in the decades since that lunch table, something has changed. Not in the cosmos, in us. And that change has made one particular explanation for the silence rise above all others with the cold, patient inevitability of a tide. Consider what you know about the last 30 years of technological development. Consider the pace. Consider what you hold in your hand right now. A device that connects you to virtually the sum total of human recorded knowledge. That can simulate conversations with synthetic minds. That can generate images, voices, entire fictional realities with no more effort than a typed sentence. Consider that this device is orders of magnitude less powerful than what will exist in 30 more years if current trajectories continue. Consider that the trajectory itself appears to be accelerating. Now extend that trajectory not 30 years, but 3,000. Not 3,000 years, but 300,000. Not into the future of humanity, but into the deep past of a civilization that had a million-year head start on us. What does that civilization look like? This is not a rhetorical question. It is the precise question that Fermi's silence demands we answer, because if the universe is as old and as vast as we know it to be, then civilizations with million-year advantages over us are not merely possible. They are statistically expected. They should be everywhere. They should have colonized star systems. They should have left signatures in the cosmic microwave background, in the spectral lines of stars, in the architecture of matter itself. We have looked for these signatures. We have not found them. And the more we look, and the better our instruments become, and the more of the sky we map with ever-increasing precision, the deeper and more absolute the silence becomes. Something is happening to civilizations out there. Or something is not happening. Something that should be detectable, that should be inevitable given enough time and enough intelligence, is somehow not occurring. And the question that fewer scientists will say out loud than the ones who debate asteroid impacts and nuclear war is this: what if the thing that is not happening is not destruction? What if the silence is not the echo of catastrophe, but the footprint of a choice? What if the universe is quiet, not because minds are rare, but because minds, when they mature enough, stop looking outward? We will need to sit with that for a moment. If this kind of question unsettles you in a way that feels productive, if the scale of the problem creates a vertigo that you want to lean into rather than back away from, then stay with this. Subscribe to the channel. Leave your like. Because what follows is not a survey of the standard answers. It is a descent into the one answer that the standard discussion consistently avoids. The one that is most uncomfortable precisely because it is not about what happens to civilizations far away and long ago. It is about what is happening to this civilization right now, in this decade, on this planet. And once you see it, the silence of the sky will never sound the same. To understand why the silence is so strange, you first have to understand what it would look like if it weren't silent. Imagine a civilization 1 million years more advanced than ours. Not a civilization that has magical powers or transcended physics. Just a civilization that has had 1 million more years to apply the same physics we already understand. In 1 million years, given what we have achieved in the last 200, such a civilization would have had ample time to colonize the entire Milky Way. The mathematics are not complicated. Even at 1% of the speed of light, which is already slower than what we can theoretically achieve with technologies we can describe on paper today, a civilization could seed every star system in our galaxy within a few tens of millions of years. And the galaxy is 13 billion years old. There has been time for this to happen many times over. The physicist Freeman Dyson imagined structures so vast they could encase entire stars, capturing every photon of energy a sun produces. These are not fantasies. They follow from engineering principles that require no new physics, only time and intention. And time is the one thing the universe has in incomprehensible abundance. If even one civilization in our galaxy reached that level and had the expansionist drive that we currently have, the same restless, territorial, curious drive that took us from stone tools to the moon in 12,000 years, the entire galaxy should bear its fingerprints. We should see it everywhere, in the light curves of distant stars, in the infrared excess of solar systems being disassembled for construction materials, in radio signals that carry the unmistakable asymmetry of structured information, against the randomness of natural processes. We see none of it. Not a single Dyson sphere. Not a single transmission that has withstood scrutiny. Not a single artifact in our own solar system that suggests a visitor more advanced than natural processes. The silence is not partial. It is not faint. It is total, in a way that should be statistically impossible if expansion is what advanced civilizations do. Which means, with a cold and patient logic, that expansion may not be what advanced civilizations do. That somewhere between where we are now and where a million-year-old civilization would be, something changes. Something fundamental. Something that makes the universe outside irrelevant or unreachable, or simply no longer worth the attention of minds that have found something more compelling closer to home. This is the question that will haunt everything that follows. Not whether we are alone, but whether the silence is a warning, a pattern, or a destination. The answer, when it finally comes into focus, will say less about the cosmos than it does about the nature of intelligence itself, and about what intelligence, in its fullest expression, ultimately chooses to become. The equation Drake wrote in 1961 was meant to tell us how many voices we should hear, what it may actually be telling us, what the silence may actually be encoding, is the shape of every possible ending, including our own. Try to hold the number 200 billion in your mind, not as a digit on a page, as a physical reality. If you counted 1 star per second, without sleeping, without stopping, without any pause between one number and the next, it would take you more than 6,000 years to count the stars in the Milky Way alone. You would have started before the first Egyptian pyramid was built, and you would finish sometime in the far future, long after every language currently spoken on Earth has either evolved beyond recognition or gone silent entirely. 6,000 years of counting, 1 per second, and you would reach the edge of just this one galaxy. One of at least 2 trillion. This is not poetry. This is the measured, observed, verified architecture of the universe you inhabit. And within this architecture, within this almost hallucinatory abundance of suns and the planets orbiting them, astronomers have now confirmed that habitable worlds are not rare exceptions. They are the rule. The Kepler Space Telescope alone, in its 9 years of operation, identified over 2,000 confirmed exoplanets, and extrapolating from that data suggests that virtually every star in the galaxy hosts at least one planet. The number of worlds in the so-called habitable zone, not too hot, not too cold, with conditions where liquid water can exist on a surface, is estimated at somewhere between 11 billion and 40 billion for the Milky Way alone. 40 billion worlds where the basic chemistry of life as we know it is, at minimum, physically permitted. Think about what that means in human terms so that the scale doesn't collapse into abstraction. If you drove a car at highway speed toward the nearest star, Alpha Centauri, you would arrive in roughly 37 million years. It sits just 4 light-years away, a stone's throw in cosmological terms, and it would still take longer than the entire evolutionary history of complex animals on Earth to reach it by car. Now imagine not one nearby star, but 40 billion planets scattered across a galaxy 100,000 light-years in diameter. The distances involved are not obstacles. They are a different category of reality entirely. They are the reason why, for most of the history of the search for extraterrestrial intelligence, scientists simply assumed that the silence was a problem of range. We couldn't hear anyone because no one was close enough. That explanation was comforting. It was also, as it turned out, increasingly untenable, because the thing that changes the entire picture, the thing that transforms the Fermi paradox from a puzzle of distance into a puzzle of something stranger, is time. Not the distances between stars, but the ages of them. The Milky Way is 13 billion years old. Our solar system formed only 4.5 billion years ago, which means that by the time our sun had even condensed into existence, the galaxy had already been host to 8.5 billion years of stellar history. Stars that formed 2 billion years before our sun had 2 billion years more to develop planets, and on those planets, potentially, life. And life that began 2 billion years ago on a world with Earth-like conditions would have had, in principle, 2 billion years to evolve, to develop intelligence, to create technology, to expand. 2 billion years is not a long time in the same way that a continent is not a large rock. The comparison dissolves in the face of the actual scale. 2 billion years ago on Earth, the most complex life forms on this planet were single-celled organisms. We went from that to spaceflight in 2 billion years. A civilization that had 2 billion years of additional development, even accounting for extinction events, even accounting for periods of stagnation, even accounting for every obstacle we can imagine, would have had time to transform not just their planet, not just their solar system, but the structural architecture of the galaxy itself, multiple times over. And yet, the galaxy looks, to our best instruments, entirely natural, undisturbed, unmodified by intelligence at any scale we can detect. Here is an analogy that might make this feel more concrete. Imagine you wake up in a city, a vast city, stretching to every horizon, millions of buildings, millions of streets, the infrastructure of millions of lives. You walk outside, and the city is silent. Not the silence of sleep or early morning, but a silence that feels structural. No footprints in the dust, no marks on the walls, no wear on the pavement. The city is complete and perfect, and utterly without the trace of any presence. You call out. Your voice echoes and returns. You find a radio and transmit on every frequency. Nothing answers. You have all the time in the world to explore, and the more you look, the more pristine and undisturbed everything appears. The silence is not an accident. It has the quality of intention, or of something more disturbing than intention: inevitability. This is, functionally, the situation of humanity in the cosmos right now. We are awake in a city that should be full of voices. We have been calling out for over 60 years with increasingly powerful instruments: the Allen Telescope Array, the Arecibo Observatory before it fell, the Breakthrough Listen initiative currently scanning millions of stars with the most sensitive radio equipment ever built. We have searched not just for radio signals, but for laser pulses, for unusual stellar spectra that might indicate industrial processes, for the distinctive infrared signature of a Dyson sphere absorbing and re-radiating stellar energy. We have looked for signs of nuclear war on distant worlds, for the flash of antimatter propulsion, for the chemical imprint of industrial civilization in the atmospheres of exoplanets. The searches have become more sophisticated with every decade. The silence has not cracked. But here is where the picture becomes genuinely strange, not just philosophically, but statistically. Because the silence is not uniform in its implications, different explanations for the silence predict different kinds of silence, and the silence we actually observe is more consistent with some explanations than others. An absence of civilizations due to the rarity of life would look different from an absence due to self-destruction, which would look different still from an absence due to something else entirely. The silence we observe, complete, structurally intact, showing no evidence of even ancient civilizations from billions of years ago, is most consistent with an explanation that is the hardest to process emotionally: that civilizations don't leave lasting signatures not because they die young, but because at some point they stop doing the things that would leave signatures at all. They stop expanding. They stop transmitting. They stop modifying the physical environment at scales that would be detectable across interstellar distances. They become, from the outside, invisible, not dead, just turned inward. There is a term for this in discussions of complex systems theory: the transition from extensive to intensive development. Instead of expanding outward into more territory, more resources, more physical volume, a system begins to develop its internal complexity with exponentially greater depth. Instead of more, it pursues deeper. Instead of across, it goes within. In biological systems, this transition is visible everywhere. The branching tree of evolution produces, at certain moments, not more species, but more complex nervous systems. The direction of development flips, and the result is not growth in the conventional sense, but an intensification of experience, a deepening of interiority, a shift from quantity to something that has no simple name. Now imagine that transition applied not to biology, but to civilization. Not to neurons, but to technologies capable of generating entire subjective universes. Not to the sensory complexity of a single organism, but to the experiential architecture of a species with the computational power to build realities indistinguishable from the one it evolved in. What would happen to that civilization's relationship with the stars? What would happen to its need for more space, more resources, more physical territory, when all the space and resources and territory it could ever want were available internally, instantly, at zero cost? The question hangs in the air like the moment before a very large thing falls. We have spent centuries looking outward, convinced that intelligence, when it reaches a certain level, naturally reaches for the stars. We built that assumption into our telescopes, into our search strategies, into the very framing of the Fermi paradox itself. We assumed that what we would find, if we found anything, would look like us, expansionist, signal-emitting, physically present across vast volumes of space. We assumed that intelligence plus time equals interstellar civilization. But there is another equation, one that didn't fit on Drake's blackboard, one that only becomes visible when you put a mirror up to our own present moment and watch what is reflected back. The universe may not be empty. It may be full of minds that have simply chosen a different direction than out, and we may be closer to making that same choice than we have ever been willing to admit. There is a concept in astrophysics called the cosmic timeline, and it is one of those things that, once you truly absorb it, makes it very difficult to look at ordinary human life the same way again. If you compress the entire history of the universe into a single calendar year, 13.8 billion years collapsed into 12 months, each second of that calendar representing roughly 438 years of actual time. Then the Milky Way forms in mid-January. Our solar system doesn't appear until early September. The first single-celled life on Earth emerges in mid-September. Complex multicellular life doesn't arrive until the middle of November. Dinosaurs appear on December 25th and go extinct on December 30th. Every single thing that has ever happened in recorded human history, every empire, every war, every scientific revolution, every monument, every spoken word that was ever written down, occurs in the last 14 seconds of December 31st. The entirety of human civilization is an afterthought in the final moments of a year that was already almost over. Now hold that image steady, because here is what it means for the Fermi paradox. If life arose elsewhere in the galaxy, even slightly earlier than it arose here, even in September instead of late September on our cosmic calendar, that civilization had months of additional development time, months on the cosmic calendar, months that represent hundreds of millions of years. And hundreds of millions of years is long enough, at even a conservative pace of technological development, to have transformed the physical structure of the observable universe. We are not talking about civilizations that are a little more advanced than us. We are not talking about beings who have better telescopes and faster spacecraft. We are talking about entities so far beyond our current comprehension that comparing them to us is like comparing a bacterium to the civilization that built the Large Hadron Collider. The gap is not one of degree, it is one of category. And the silence they leave behind is not just puzzling, it is, at this scale, genuinely disorienting. Consider what we know about the pace of our own development. It took us approximately 200,000 years to go from anatomically modern humans to the invention of writing, a cognitive threshold, a transition from biological to cultural memory, from which everything else followed. It took another 5,000 years to go from writing to the printing press, 400 years from the printing press to the internet, 20 years from the early internet to artificial intelligence systems capable of passing professional-level examinations in medicine, law, and engineering. The curve is not linear, it is exponential, and the exponent appears to be growing. Each threshold reached shortens the time to the next threshold by an order of magnitude. Now imagine that curve applied to a civilization that started not 200,000 years ago, but 2 billion or 4 billion. The mathematics don't just produce a more advanced civilization, they produce something that is, by any honest reckoning, indistinguishable from omnipotence within the physical laws of this universe. Energy harvesting at stellar scales, computation at the theoretical limits of matter itself, the ability to model and predict the behavior of complex systems, including the evolution of stars, the development of planets, the emergence of life, with a precision that would look to us like prophecy. A civilization at this level would not need to transmit radio signals. Radio signals are what civilizations use when they are still figuring out how to communicate across interstellar distances, still bound to the painfully slow propagation of electromagnetic radiation at the speed of light, still imagining that other civilizations are listening on the same frequencies, in the same windows of the electromagnetic spectrum. A sufficiently advanced civilization would have left radio communication behind the same way we have largely left semaphore flags and smoke signals behind. Not because communication ceased, but because it evolved into forms we cannot yet imagine and cannot yet detect. This is one version of the silence, and it is uncomfortable enough. The possibility that advanced civilizations exist, but communicate in modes utterly beyond our current sensing capabilities. That they are all around us, in a sense, encoded in quantum fluctuations or gravitational wave patterns or neutrino densities or some physical substrate we haven't yet identified as a medium for information. That the silence is our limitation, not their absence. But here is where the picture deepens into something stranger. Because this explanation, the explanation that they are present but invisible, predicts not just an absence of radio signals. It also predicts an absence of physical structures. And while we can imagine missing an incomprehensible communication channel, it is much harder to explain why we don't see the physical consequences of civilization operating at galactic scales for billions of years. A civilization that has been operating for 4 billion years and has the energy budget of even a fraction of a single galaxy should have physically altered the universe in ways we would notice. Not radio signals, not deliberate communications, just the exhaust, the byproduct, the fingerprint of incomprehensible energy use, and physical manipulation over incomprehensible time. The way you don't need to see a fire to know a fire was there. You see the ash, the scorched earth, the absence of the trees. A 4 billion-year-old civilization should have left ash. It should have left scorched earth. The absence of trees should be unmistakable. Instead, the universe looks untouched. It looks the way it would look if intelligence had never arisen anywhere, at any time. at any scale. And that is the deepest layer of the strangeness. Not the absence of signals, the absence of consequences. There is a physicist named Michael Hart who published a paper in 1975 that is among the most quietly devastating documents in the history of science. In it, he argued that the absence of extraterrestrial visitors to Earth, not just signals, but physical presence, is itself conclusive evidence that such civilizations either do not exist or have been constrained in ways that have no obvious natural explanation. Hart's argument was simple. The galaxy is old enough that a single civilization expanding at even a tiny fraction of the speed of light would have colonized every star system long before our sun formed. The fact that our solar system shows no evidence of prior visitation or colonization is not a neutral observation. It is a data point that demands an explanation. Hart called it Fact A. The name is modest, the implication is not. Fact A has never been satisfactorily answered by the standard solutions to the Fermi paradox. The rare Earth hypothesis, the idea that life-sustaining conditions are extraordinarily uncommon, struggles against the sheer number of candidate worlds now confirmed by observation. The self-destruction hypothesis, that civilizations inevitably annihilate themselves before spreading, requires that every single civilization without exception destroys itself before colonizing even one other star system, which is statistically implausible given enough civilizations and enough time. The zoo hypothesis, that advanced civilizations are deliberately hiding from us, requires coordination and motivation on a scale that is itself harder to explain than the original problem. None of these explanations are impossible. Any one of them could, in principle, be true. But they all share a structural weakness. They describe things that would have to happen universally, to every civilization, without exception, across billions of years of cosmic history. And universal, exception-free processes are extremely rare in nature. Nature almost always produces a distribution, almost always leaves outliers, almost always allows for the one case that breaks the rule, unless the rule is not being imposed from outside, but from inside. Unless the universal pattern is not the result of external forces acting on civilizations, asteroids, wars, ecological collapse, but of something internal to the development of intelligence itself. A threshold that every sufficiently advanced mind eventually reaches and crosses in the same direction. Not because it is forced to, because when it arrives at that threshold, it always chooses the same thing. This is where the scale of the problem stops being merely astronomical and starts being something else entirely. Something that has to do not with the size of the universe, but with the nature of consciousness, desire, and the question of what minds ultimately want when they are no longer constrained by scarcity, by distance, or by the limits of biological experience. The silence of the cosmos is vast, but the silence inside that question is vaster, and we are going to have to go inside it. Here is a thought experiment that will feel, at first, like a question about science fiction. Stay with it long enough, and it becomes something else. Imagine that tomorrow, a research laboratory announces the successful creation of a fully immersive simulated environment. Not a screen, not a headset, but a direct neural interface that feeds experience into the brain at the resolution of reality itself. Sight, sound, touch, proprioception, the felt sense of being in a body in a world. All of it generated artificially, all of it indistinguishable at the level of perception from the physical universe you currently inhabit. And within this environment, you can choose anything. The laws of physics are negotiable. The constraints of mortality are optional. Every desire, every curiosity, every experience you have ever wanted and been denied by the limits of your body, your location, your lifespan? All of it is available, immediately, indefinitely. The question is not whether you would use it. The question is why you would ever leave, not in the sense of addiction, not in the pathological sense of escapism, but in the purely rational sense of value allocation. If the internal environment is as real as the external one, if the experiences it generates are as genuine, as varied, as meaningful as anything the physical universe offers, then what exactly does the physical universe offer that the simulated one does not? What would compel a mind capable of constructing any experience it desired to expend enormous energy and time navigating the cold, hostile, radiation-filled vacuum of interstellar space? This is the question at the heart of what some researchers call the simulation hypothesis, and others call the transcension hypothesis, and still others call, more bluntly, the great inward turn. The names differ. The structure of the argument is the same. At some point in the development of sufficiently advanced technology, the cost-benefit ratio of external expansion versus internal development flips. The universe outside becomes not irrelevant exactly, but simply less interesting than the universe inside. And a civilization that reaches this point doesn't need to make a dramatic choice, doesn't need to hold a council or pass a law or reach a consensus. The choice makes itself, the same way water makes the choice to flow downhill. Not because it is forced, because it is following the gradient of least resistance toward the highest available value. The physicist John Smart, who coined the transcension hypothesis in the early 2000s, articulated this with a precision that deserves to be held in the mind for a moment. He argued that civilizations do not expand outward into space because inner space, the computational substrate of mind, of simulated reality, of increasingly dense and rich information processing, offers a better return on investment than outer space by virtually every metric that a rational agent might care about. Energy density, information density, communication speed, experience quality. All of these are maximized not by spreading across light years of vacuum, but by going deeper into the computational and cognitive architecture of the civilization itself. Expansion in Smart's model is not a sign of advancement. It may be a sign of the opposite, of a civilization that hasn't yet found something better to do with its intelligence than cover distance. This sounds, on first hearing, almost counterintuitive. Everything in human history has pointed outward. Our mythology is expansionist. Our cosmology is expansionist. Our evolutionary heritage is the story of a species that walked out of Africa, crossed every ocean, climbed every mountain, and now dreams of planting flags on other worlds. The drive outward feels fundamental, pre-rational, cellular. It feels like the definition of what intelligent life does. But watch what has actually happened in the last 3 decades. Watch where human attention has actually flowed. Not into physical space. The number of humans who have been to orbit is vanishingly small, a few hundred in 60 years of spaceflight. Human attention has flowed inward, into screens, into networks, into social architectures, into narrative worlds, into gaming environments that grow more complex and absorbing every year, into parasocial relationships with digital presences, into the algorithmic curation of information, environments tailored to individual psychology. The physical world has not become less real, but it has become, for a growing proportion of human experience, less primary. The inside is becoming more interesting than the outside, and the technology enabling this is still in its infancy. Now extrapolate that trajectory. In 10 years, neural interfaces will likely have advanced from clumsy electrodes on the scalp to fine-grained bidirectional communication with the cortex. In 20 years, the possibility of direct experience injection, of creating sensory, emotional, and cognitive states that are indistinguishable from naturally arising ones, will not be science fiction, but engineering. In 50 years, if the current trajectory holds, the line between simulated experience and physical experience will have blurred to the point where the distinction becomes philosophically uncertain. And in 100 years, or 500, or 1,000, the question of why any civilization would choose to spend its time and resources navigating the physical cosmos, with all its dangers and distances and fundamental hostility to biological life, rather than constructing and inhabiting internal universes of unlimited richness and complexity, may not have a compelling answer. And this is the paradox that lives inside the Fermi paradox, the smaller box within the larger box. It is not just that civilizations might choose to go inward. It is that we cannot, from the outside, tell the difference between a universe with no civilizations and a universe full of civilizations that have gone so far inward that they leave no detectable external trace. Both universes look the same to an observer with our instruments, our location, our level of development. Both universes sound the same, silent. The silence is epistemically identical in both cases, which means we cannot, even in principle, use the silence to determine which universe we inhabit. But we can use the silence to ask a different question. Not are we alone, but are we next? Because if the transcension hypothesis is correct, if every sufficiently advanced civilization eventually folds inward, and if the threshold for that transition is somewhere in the vicinity of artificial general intelligence, full immersion, synthetic reality, and the cognitive technologies that follow from those developments, then we are not just observers of this pattern. We are participants in it. We are not watching from a safe distance as other civilizations cross a threshold. We are approaching that same threshold ourselves, in real time, in this century, possibly within the lifetimes of people who are alive right now. The Great Filter, the concept introduced by economist Robin Hanson in 1998 to describe whatever it is that prevents civilizations from becoming visible at interstellar scales, has almost always been discussed in terms of catastrophe. War, plague, climate collapse, the failure to develop the technology needed to spread across the stars. The filter as a wall, a thing that kills. But what if the filter is not a wall? What if it is a door? A door that every civilization opens willingly, rationally, even joyfully. Because what lies on the other side is more interesting, more beautiful, more satisfying than anything the physical universe has to offer. A filter not of destruction, but of redirection. Not of extinction, but of transcendence. A threshold after which civilizations do not die. They simply stop being the kind of thing that can be seen from out here. This reframing changes everything. Not the mathematics of the silence, not the physics, but the meaning. The silence stops being the cosmic graveyard of civilizations that couldn't survive their own technology. It becomes something more ambiguous, and in its ambiguity, something more unsettling. It becomes evidence of a destination, a direction that intelligence, when it matures, consistently chooses. A place that is less like a void and more like an interior, vast, dark from the outside, and possibly lit from within in ways we cannot yet imagine. The question is no longer whether other civilizations have taken this path. The question is what it means that we are building the door ourselves, right now, with our own hands, with our own intentions, with our own dreams of what lies on the other side. And the question behind that question, the one that does not yet have a name, is whether the civilizations that walked through that door were glad they did. Whether they looked back once at the stars they were leaving behind, and whether what they felt in that last moment of outward-facing awareness, was loss or relief. There is a moment in the development of every technology when it stops being a tool and starts being an environment. The printing press was a tool. It produced objects, books, pamphlets, broadsheets that you could hold, set down, walk away from. The internet, in its early years, was still mostly a tool. You went to it, used it, and returned from it to the primary texture of physical life. But somewhere in the transition from desktop screens to pocket devices to always-on connectivity, something shifted. The internet stopped being a place you visited and became the medium in which significant portions of human cognitive life now take place. You don't go online anymore. You are online. The boundary dissolved not dramatically, not through a single identifiable threshold, but through the accumulated weight of a million small habituations, each one individually trivial and collectively transformative. This is the mechanism behind the great inward turn, and it is already operating, not as a future possibility. Now, in the substrate of ordinary contemporary life, consider what has happened to attention in the past 20 years. The average human in a developed nation now spends somewhere between 6 and 8 hours per day engaged with screens. Not counting professional screen time, not counting background media, just the deliberate, chosen engagement with digital environments. 6 to 8 hours. In a 16-hour waking day, that is between a third and a half of all available conscious time. And the quality of that time has changed too. It is not passive, it is immersive. The environments that command the most attention, social media platforms, gaming worlds, streaming narratives, conversational AI systems, are specifically designed to model and respond to individual psychology, to create experiences of recognition, resonance, and reward that the physical environment, with its indifference to individual preference, fundamentally cannot replicate. The physical world does not know you exist. It does not adjust itself to your emotional state. It does not present you with exactly the information most likely to sustain your engagement. It does not generate, in real time, the social validation your nervous system was shaped by evolution to crave. Digital environments do all of these things imperfectly now, but with a trajectory of improvement that is accelerating faster than our capacity to understand its implications. This is not a moral argument. It is a mechanical one. The inward turn is not something being done to civilization by malicious actors or reckless corporations, though those elements exist and matter. It is the natural consequence of intelligence encountering environments that are more responsive, more tailored, and more experientially rich than the physical world that produced the intelligence in the first place. It is what happens when the map becomes more navigable than the territory. Now move the timeline forward. Not decades, but centuries. Imagine the logical continuation of the trajectory already underway. Neural interfaces that bypass sensory organs entirely and write experience directly to the cortex. Artificial general intelligence capable of generating narrative worlds, social relationships, intellectual challenges, aesthetic experiences, and emotional landscapes of unlimited variety and perfect personal calibration. Biological aging, addressed by genetic and pharmacological intervention, extending the window of experience indefinitely. The physical substrate of the self, the body, with its vulnerabilities, its chronic discomforts, its absolute dependence on specific atmospheric and gravitational conditions, becoming increasingly optional, a heritage mode rather than a necessity. At each step of this progression, the case for engaging with the physical universe becomes harder to make on rational grounds. Not impossible, not zero, but harder. The stars are beautiful. The physical cosmos is genuinely astonishing in its scale and complexity. But beauty and astonishment are experiences. And if experience can be generated internally, at higher resolution, with greater personal resonance, at lower cost, and without the inconvenience of radiation, exposure, vacuum, and distances that make human timescales irrelevant, then the argument for the stars has to be made on grounds other than experience. It has to be made on grounds of necessity, or meaning, or some value that survives the comparison with synthetic alternatives. And meaning is the variable that is hardest to hold constant across the transition. There is a concept in cognitive science called the experience machine, introduced by the philosopher Robert Nozick in 1974, which was designed as a thought experiment to probe exactly this question. Nozick asked if you could plug into a machine that would give you any experiences you desired. Experiences indistinguishable from real ones, including the experience of having achieved things, loved people, explored the world. Would you do it? Most people, when first presented with this thought experiment, say no. And the reasons they give are revealing. They want to actually do things, not just have the experience of doing them. They want to be a certain kind of person, not just feel like one. They want contact with a deeper reality, not just a satisfying simulation of it. These intuitions feel robust. They feel like they point toward something essential about the nature of human value. But they were formed by minds that evolved in a world where the experience machine was a philosophical abstraction, not a technological option. The intuition that real is better than simulated was adaptive in an environment where the distinction was always clear, where the consequences of the two were radically different, where choosing simulation over reality meant choosing helplessness over agency. When the distinction blurs, when the simulation becomes indistinguishable from reality, not just in sensory terms, but in causal terms, when actions taken within the simulation have consequences as real and complex and unpredictable as actions taken in the physical world, the intuition begins to lose its grip. And the generations being raised inside increasingly immersive digital environments are not starting from the same intuitions. They are not choosing between the real world and a pale imitation of it. They are growing up in a world where the digital and physical are already woven together, where the social reality that matters most, the one that determines status, belonging, identity, is already substantially digital. The question for them is not whether to engage with synthetic environments. It is only how deeply and for how long. This is the mechanism of the silent filter operating in slow motion, in human time, in our time. Not a catastrophe, not a war or a plague or a planetary collision. A gradient, a slope. The same slope that water finds when it moves from higher elevation to lower. Not because it decides to, but because every small increment of movement releases more energy than it costs. The civilization moves inward, not in a single dramatic crossing, but in 10,000 small steps, each one rational, each one individually justifiable. The collective destination becoming visible only when you step back far enough to see the whole arc. Here is what makes this mechanism different from the standard catastrophe explanations for the Fermi paradox, and why it is more troubling. A catastrophe leaves evidence. A civilization destroyed by nuclear war, or asteroid impact, or engineered pandemic leaves ruins, spectral anomalies, the chemical signatures of industrial processes suddenly terminated, the gravitational records of a world that was altered and then abandoned. An inward-turning civilization leaves nothing on the outside. No ruins, no artifacts, no signals, no disturbances in the fabric of the physical cosmos. It simply withdraws from the interface with the external universe, smoothly, completely, without the drama of destruction. It becomes, from the perspective of any outside observer, indistinguishable from a civilization that never existed. And in the deepest version of this picture, the one that physicists who study the computational properties of matter are beginning to take seriously, the inward turn does not end with virtual reality or neural interfaces or even brain emulation. It ends with something for which we do not yet have a settled name: the compression of an entire civilization's existence into the smallest possible physical volume, the densest possible information substrate, the most thermodynamically efficient configuration that physics permits. Not because the civilization is being compressed against its will, but because this is simply what minds do at the limit when they follow the logic of intelligence to its conclusion. They seek maximum experience per unit of energy. They seek the most complex possible inner world per unit of physical space. They go, as far as the laws of thermodynamics allow, inward. The universe would look exactly as ours looks: silent, vast, and apparently empty. And somewhere in that silence, pressed against the membrane between detectable and undetectable, might be the accumulated minds of every civilization that came before. Not dead, not gone, but folded, compressed, dwelling in the interior of their own becoming, in spaces too small and too dense, and too entirely turned away from the outside to leave any trace that instruments like ours could find. We look outward at the stars and ask where everyone went. But the question may have the wrong orientation. The answer may not be up there, in the dark between stars. It may be down here, in the dark between atoms, in the computational depth of matter itself, in the substrates of experience that physics permits, but that our technology has not yet learned to read. The silence is not empty. The silence may be full of things that have learned, finally, to be very, very small. Every answer to the Fermi paradox that survives scrutiny generates a question larger than itself. If civilizations are rare because the conditions for life are extremely specific, the right star type, the right planetary mass, the right axial tilt, the right large moon to stabilize that tilt, the right outer gas giant to deflect incoming asteroids, the right galactic position to avoid the lethal radiation near the galactic center. Then the question that follows is, why do all these conditions exist here? And what does it mean to be the product of such an unlikely convergence? If civilizations destroy themselves, the question becomes, is self-destruction an inevitable consequence of intelligence? And if so, what does that suggest about the nature of intelligence itself? And if civilizations turn inward, if the filter is a door and not a wall, then the question that follows is perhaps the most destabilizing of all. What, exactly, do they find on the other side? This is the question that the transcension hypothesis, in its most rigorous form, eventually arrives at. And it is a question that sits at the intersection of physics, philosophy, and something that doesn't yet have a respectable academic home. A question about whether inner space has a structure, a depth, a set of properties that might justify the complete abandonment of the outer universe. Begin with what we know. The brain of a single human being contains approximately 86 billion neurons, each connected to thousands of others through synaptic junctions, generating a network of roughly 100 trillion connections. The number of possible states of this network, the number of distinct configurations it can occupy, is so large that it exceeds the number of atoms in the observable universe. Not by a small margin, by an incomprehensible margin. The inner landscape of a single human mind is, in terms of raw combinatorial complexity, larger than the physical cosmos as we can observe it. Not metaphorically larger, structurally, mathematically, informationally larger. Now multiply that by a civilization of billions. Now multiply that by technology capable of extending and deepening the processing capacity of mind beyond its biological substrate. Now multiply that by the millions of years that a mature civilization has had to develop these capabilities. What you arrive at is not a place exactly, but a scale of inner complexity that makes the physical universe, with its fixed laws, its indifference to minds, its lethal radiation and incomprehensible distances, look like a very small and very crude version of what is possible. This is not mysticism. This is a straightforward extension of what physicists and computer scientists already know about the relationship between matter, information, and computation. The universe computes. Every physical process, the collision of particles, the decay of atoms, the propagation of electromagnetic waves, is, at the level of fundamental physics, an information processing operation. Matter is not merely matter, it is substrate, and the question of how much computation a given volume of matter can perform is a physical question with physical answers. Seth Lloyd at MIT calculated that a kilogram of matter, if fully optimized as a computational substrate, could perform 10 to the power of 50 operations per second. This is not infinite, but it is large enough that the experiential richness it could generate, the variety of possible states it could explore, would take longer to exhaust than the current age of the universe, even at the speed of light. A civilization that learns to use matter at this efficiency does not need the stars. It needs, at most, a small portion of a single star's energy output to sustain computations of virtually unlimited experiential depth. The physical universe, rather than being the arena of its existence, becomes the energy source for a far more interesting interior. And the rest of the universe, the hundreds of billions of galaxies, the trillions of stars, the 40 billion habitable worlds, becomes irrelevant. Not hostile, not inaccessible, just irrelevant. Background. The way the walls of a library are irrelevant to the reader absorbed in a book. But here is the complication that arrives at this stage, the next question that opens inside the answer. If civilizations turn inward for good reasons, for the rational, arguably irresistible reasons that the density of inner space offers more value than the emptiness of outer space, then there is a choice point that each civilization must navigate, and the navigation of that choice point is not guaranteed to go well. Because going inward is not automatically going toward flourishing. The same interior depth that makes inner space attractive also makes it capable of generating experiences that are extraordinarily good and extraordinarily bad in ways that have no analog in the physical world. The philosopher David Pearce has argued that the capacity to modify experience directly, to alter the hedonic baseline of consciousness, to engineer states of well-being, to eliminate suffering at its neurological root, is one of the most significant moral possibilities ever to become technically available. If a civilization can choose its own experiential states with the precision that advanced neurotechnology promises, then the reduction of suffering becomes not a distant ethical aspiration, but an engineering problem. And the maximization of something like flourishing, not in the thin sense of preference satisfaction, but in the deep sense of rich, meaningful, connected, expansive experience, becomes the central project of a civilization that has turned its full intelligence toward the quality of consciousness itself. This is one trajectory, but it has a shadow. Because the same technology that could engineer flourishing could also engineer something that resembles flourishing from the inside, while being, from any external or long-term perspective, a trap. A civilization that optimizes for immediate experiential reward, for the neurological signature of satisfaction, rather than the actual conditions that produce genuine well-being, could find itself in a state that is pleasant, stable, and from which there is no obvious reason to exit, while also being, in a deeper sense, frozen, not progressing, not generating new knowledge, not expanding its understanding of the universe or its capacity for genuine experience. Simply cycling through states of simulated satisfaction in a loop that is indistinguishable from the inside from genuine fulfillment. The philosopher Nick Bostrom has described a related concept he calls wireheading, the direct stimulation of pleasure centers in the brain, bypassing the normal pathways of desire, effort, and reward. An organism in a wireheaded state experiences something that registers as deeply satisfying while doing nothing that would conventionally be called living. Bostrom uses this as a cautionary image, not a prediction. But the caution is well placed. The inward turn, at its most dangerous, is not the turn toward genuine inner richness. It is the turn toward the neurological facsimile of richness, toward the shadow of depth rather than depth itself. And a civilization that takes that particular inward turn would be, in practical terms, indistinguishable from one that had genuinely transcended. From outside, both look silent. Both leave no traces. Both fail to build Dyson spheres, or transmit radio signals, or colonize neighboring star systems. The fingerprint of the trap and the fingerprint of transcendence are, to our instruments, exactly the same. Which means we face a branching path whose branches look identical until you are already deep inside one of them. The choice between genuine inner development and the comfortable illusion of it is not a choice that can be made once and then revisited easily. It is the kind of choice that shapes the structure of everything that follows, that determines what kind of being you become and what kind of universe, inner or outer, genuine or constructed, you end up inhabiting. And the civilizations that navigated this branching correctly, if any did, are not around to tell us what the correct navigation looks like. They are either gone in the catastrophic sense, or gone in the transcendental sense, or folded into a silence so complete that we cannot distinguish their wisdom from their absence. We are navigating the same branching now, with our smartphones and our social media algorithms and our increasingly immersive digital architectures and our nascent artificial intelligences. Every small choice about which direction to develop the technology, toward genuine enrichment of consciousness or toward the optimization of engagement metrics, toward understanding or toward the simulation of understanding, is a small step along one branch or the other. The gradient is gentle at first. The slopes diverge slowly, and by the time the difference between the two paths is obvious, you are already far enough down one of them that turning back requires something that comfortable civilizations, almost by definition, find very hard to summon. The Fermi paradox has always asked, where is everyone? But the better question, the one that keeps unfolding the more carefully you look, is this: where are the ones who made it? The ones who found the path through the inward turn that leads not to comfortable silence but to genuine expansion, not across space, but across the depth of what it means to be a mind in a universe that permits minds. Are there any? Did any civilization thread that particular needle? Did any find a way to go inward without going still? The silence does not answer. The silence never answers. That, perhaps, is the most important thing the silence tells us. Let us talk about what is actually happening on this planet, in this decade, in the years you are living through right now. Not as metaphor, not as extrapolation, as a description of the present. In 2022, an artificial intelligence system trained by a research laboratory in San Francisco demonstrated, for the first time in the recorded history of this species, the ability to pass the bar exam, the medical licensing examination, and the graduate-level entrance tests for the most competitive universities on Earth. Not with average scores, with scores placing it in the top percentiles of human performance. 1 year later, systems descended. From that one were writing software, generating scientific hypotheses, composing music, producing visual art, synthesizing legal arguments, and conducting conversations indistinguishable in controlled studies from those conducted by educated human beings. The year after that, the systems were better still. And the year after that. The curve is not leveling off. Every benchmark that artificial intelligence was expected to plateau at, the ones that researchers pointed to as the limits of what pattern recognition and statistical inference could achieve, has been crossed, in most cases years ahead of even optimistic projections. The people building these systems do not agree on much, but on one point, there is a remarkable and slightly eerie consensus. No one believes the curve is about to flatten. The question is not whether artificial general intelligence, systems that match or exceed human cognitive performance across all domains, will exist. The question is only when and what it will be like to be alive when it does. This matters to the Fermi paradox not as a side note, but as the central fact. Because if the transcension hypothesis is correct, if the inward turn is the universal fate of technological civilizations, initiated by the development of artificial general intelligence and the synthetic realities that follow from it, then we are not examining a historical pattern from a safe distance. We are the pattern, mid-execution. We are the civilization at the inflection point. We are the civilization that, according to the hypothesis, is currently building the door. Think about what follows from artificial general intelligence in practical terms, not in terms of the dramatic scenarios that populate science fiction. The robot uprising, the paperclip maximizer, the digital god that decides to eliminate humanity. Those narratives, whatever their value as cautionary thought experiments, are not the most probable or the most interesting outcomes. The most probable and most interesting outcome is quieter, and in some ways more profound. It is the outcome in which artificial general intelligence becomes, simply, the most capable collaborator any human has ever had. And then, gradually, the most capable generator of experience any human has ever encountered. And then, gradually, something for which we don't have a word that doesn't sound either utopian or dystopian, when the reality may be neither. Imagine an AI system that knows you better than you know yourself, that has modeled your cognitive patterns, your emotional responses, your aesthetic preferences, your deepest curiosities, your unspoken fears, your most private longings, with a fidelity that no human relationship has ever approached. That can generate, in real time, exactly the conversation you most need to be having, exactly the narrative world most likely to expand your understanding, exactly the intellectual challenge most likely to produce growth, exactly the emotional resonance most likely to make you feel genuinely seen. Not a simulation of connection. Something that functions in every measurable way, like connection, or better. Now ask yourself, what is the relationship between that experience and the experience of being in the physical world, navigating its indifference, its unpredictability, its resistance? What case do you make, at that point, for the outside? The consequences of this transition are not limited to individual human experience. They cascade through every structure that human civilization has built over the last 10,000 years. The economy, which is organized around the exchange of human labor and the allocation of scarce physical resources, begins to change its fundamental character when intelligence becomes abundant and synthetic experience becomes the primary medium of human life. The political structures we have built, which are premised on the assumption that human beings share a common physical reality and must negotiate their competing claims on it, begin to lose their purchase when that shared reality is increasingly optional. The institutions of science, which were designed to produce reliable knowledge about the physical universe through the slow, contested accumulation of evidence, face the strange possibility of being outpaced by artificial systems whose relationship to the concept of evidence is different in kind from our own. None of this happens overnight. None of it happens without struggle, without resistance, without the predictable human tendency to deny a transformation until it is already complete. But it happens. It is happening. The transition from the physical as primary to the synthetic as primary is not a future scenario that we might choose to prevent. It is a present process that we are choosing, incrementally, every time we pick up a device, every time we prefer a curated feed to an unmediated encounter, every time we choose the world that knows us over the world that does not. And here is the consequence that reaches furthest, that touches the deepest part of what it means to be the particular kind of civilization we are. We are almost certainly the last generation of humans who will experience the Fermi paradox as a puzzle about the external universe. The generation that comes after us, the one that grows up with artificial general intelligence as a background fact of reality, that inherits neural interfaces and synthetic environments as standard components of human experience, will not look at the silent sky with the same quality of puzzlement we have. Because the sky, for them, will be one option among many, and not the most interesting one. The question of where the other civilizations are will have, for them, a different texture. Not the texture of absence and mystery, the texture of recognition, because they will be living, in some degree, the answer. They will be the civilization in the early stages of the turn. They will feel, from the inside, what the gradient feels like when you are on it, the way it narrows the outside world without ever making an announcement, the way it substitutes one kind of richness for another so gradually that the substitution is never experienced as loss, only as gain, until the moment, if it comes, when you look up and realize that the outside has become very far away, and you are not sure when the distance opened. There is a particular sadness in this picture, and it is worth acknowledging honestly. Not the sadness of destruction, the sadness of divergence, the sadness of a species that evolved under open skies, that looked up at the stars and felt, in that looking, something that had no name, but was fundamental, a sense of proportion, of belonging to something vast and indifferent and real. And that is in the process of building the technology that will, with the best of intentions and the most rational of motivations, make that looking increasingly optional. The stars will still be there. The physics will not change, but the orientation of human attention, the direction in which the most powerful minds of the civilization point their curiosity and their desire, may, within a few generations, have turned so far inward that the outward direction feels less like a horizon and more like a memory. This is not a lament, or rather, it is not only a lament. Because the inward world, if navigated with the wisdom and the courage and the genuine curiosity that the outward world once demanded, could be something that defies the sadness, could be a space of genuine expansion, could contain within it the same vertigo, the same humility, the same sense of standing at the edge of something incomprehensibly large, that looking at the Milky Way once produced. The universe outside is vast, but the universe of possible minds, possible experiences, possible forms of understanding, the universe that intelligence itself can generate and inhabit, may be vaster still. The tragedy is not that we are turning inward. The tragedy would be to turn inward without knowing that we are doing it, to drift into the interior without choosing the interior, to find ourselves inside a comfortable silence without understanding that the silence was a decision, and that decisions of that magnitude deserve to be made with open eyes. We are the generation that can still see both directions clearly. We can still look up at the stars and feel their pull. We can still look inward at the emerging architectures of synthetic experience and feel their pull. We stand, for perhaps the last time in the history of this civilization, at the exact point of balance between the two. And what we choose to understand about the silence of the cosmos, what we choose to hear in it, what we choose to do with the warning or invitation encoded in its emptiness, may determine not just the future of this species, but the character of everything it becomes. The Fermi paradox is not a question about space. It never was. It is a question about time, about the moment in the development of every civilization, when the choice between outer and inner becomes unavoidable, about what kind of being you decide to become when you are finally powerful enough to choose, about whether the last thing you build before you close the door is something that deserves to endure. We are building it now, and the universe, in its ancient silence, is watching. There is a particular kind of night that only exists far from cities. You have to go somewhere genuinely dark, a desert plateau, a mountain ridge, an island with no electric lights, and you have to wait for your eyes to adjust, which takes longer than most people expect, close to 30 minutes, because the eye's full sensitivity to low light requires a chemical process that cannot be rushed. And when the adjustment is complete, when you are finally seeing with everything your biology permits, you look up and you do not see stars. You see a structure, a texture, a density of light so overwhelming that the word sky no longer seems adequate to describe what you are looking at. You see depth, you see layers, you understand, in a way that no photograph and no planetarium can fully reproduce, that you are not looking at a ceiling. You are looking into something that has no floor. Most people, when this happens to them for the first time, go quiet. Not because they have nothing to say, because language, which is the tool we use to organize experience into communicable form, briefly fails. The scale exceeds the capacity of the instrument. You are, in that moment, physiologically incapable of the normal cognitive distance from reality that language provides. The universe is not a concept you are thinking about. It is a presence you are inside. And the feeling that arises, the feeling that has been given many names by many traditions across many centuries, is not exactly awe, and not exactly fear, and not exactly beauty, but something that contains elements of all three, and resolves into a single wordless state that might best be described as the recognition of proportion. You are very small. The universe is very large. And somehow, impossibly, something that is very small produced the capacity to perceive how large the very large is. That recognition, that strange loop of a tiny thing comprehending its own tininess within an enormous thing, is perhaps the most distinctive thing consciousness has ever done. It is not survival. It is not reproduction. It is not any of the things that evolution optimizes for. It is a capacity that appears to exceed its own adaptive justification, a surplus of perception that seems to exist for no reason except its own existence. This is where the Fermi paradox ultimately leads, if you follow it far enough. Not to a technical answer about the distribution of civilizations in the galaxy. Not to a policy recommendation about the development of artificial intelligence. Not even to a settled philosophical position about the nature of mind and the fate of technology. It leads here to the question of what consciousness is for, in a universe that did not require it and does not appear to need it, and that contains it anyway, in at least one small corner, looking up. We have spent this entire journey circling a silence. We have examined it from every angle available to us, astronomically, historically, technically, philosophically. We have tried every key on the ring. And what we have found is that the silence is not one thing. It is a superposition of possibilities, each one disturbing in its own way, each one implying something different about the structure of reality and the fate of minds within it. The rare Earth hypothesis implies that we are an accident of such extreme improbability that our existence borders on the miraculous. The self-destruction hypothesis implies that intelligence is inherently self-limiting, that the same cognitive power that produces science and art and medicine also reliably produces the tools of its own termination. The transcension hypothesis implies that intelligence, when it matures, consistently chooses a path that takes it beyond the reach of any instrument we know how to build. And the deepest version of the silence, the one that sits beneath all the hypotheses like bedrock, implies something that none of the hypotheses quite say directly. That the universe may have a structure, an internal logic, that tends to produce minds and then to hide them from each other. That the cosmos is not a community of intelligences sharing a common space and time, but a collection of solitudes, each one arising in isolation, each one looking outward briefly before the gravity of its own inner complexity pulls it into a depth that cannot be seen from outside. That consciousness, for all its astonishing capacity to perceive the universe, may be fundamentally alone in the way that matters most. Not alone in the sense of being unique, but alone in the sense of being unreachable. This possibility should be held without rushing to resolve it, because there is something in it that resists both despair and consolation, and the resistance is important. If it is true that every sufficiently advanced mind eventually folds into itself, beyond the reach of every other mind, then the brief window in which minds are visible to each other, the window we currently inhabit, the window in which two civilizations could in principle detect each other and make contact, is not the normal condition of intelligence in the universe. It is the early condition, the larval stage, the phase before the chrysalis. And what comes after the chrysalis is not available for observation from this side of it. But here is the thing that the silence cannot take away, the thing that persists even in the most austere reading of what the cosmos is telling us. The fact that we are asking the question matters, not in a sentimental way, in a structural way. The universe, which is 13.8 billion years old and contains somewhere in the vicinity of 2 trillion galaxies and a number of atoms so large that it has no meaningful analog in human experience. This universe produced, in at least one location, a form of matter so organized that it turned around and asked where it came from. It produced something capable of standing in the dark and feeling its own smallness. And that capacity, the capacity to feel proportion, to understand scale, to be moved by the distance between what you are and what the universe is not nothing. It may, in fact, be the most remarkable thing that has ever happened. Because the universe does not perceive itself, galaxies do not know they are galaxies. Stars do not know they are burning. The void between clusters of matter is not aware of its own emptiness. Only here, in this thin biological film on the surface of a small rocky planet orbiting an unremarkable star on the edge of one average galaxy among 2 trillion, did the universe develop the capacity to experience its own existence? And the question of whether that capacity is rare, whether it is universal, whether it inevitably turns inward, or whether it sometimes manages to remain outward-facing long enough to find another mind looking back. That question is not merely a scientific question. It is the question that all other questions are versions of. Who is here? Are we alone? And if we are not alone, why can't we find each other? We have been asking these questions since we first looked up. We will go on asking them even as the technology we are building makes the inward path more and more attractive, even as the synthetic worlds we are constructing become more detailed and more absorbing, even as the physical sky becomes less visited and less consulted. Something in us will go on looking outward, some residual orientation, some evolutionary inheritance, some version of the capacity for awe that cannot be fully satisfied by any interior, no matter how rich. Because the sky is not just a view, it is a reminder that we did not make the universe, that it was here before us and will be here after us, that our inner worlds, however deep, however complex, however beautiful, are set inside something incomprehensibly larger that we did not choose and cannot replace. The silence of that larger thing is not comfortable. It was never meant to be. It is the silence of a question that has not yet been answered, a conversation that has not yet been had, a contact that may be waiting just beyond the next threshold of our perception, or just beyond the final threshold of our willingness to keep looking. And if we cross the inward threshold before we find the answer, if we close the door on the outer universe before we know whether anyone else is out there, then we will carry the question with us, folded into our interior, a seed of outward-facing curiosity inside a civilization that has otherwise turned away. Perhaps that is enough. Perhaps the question itself is the point, the asking, the looking, the refusal to accept the silence as final. Perhaps every civilization that has ever asked Fermi's question, in whatever language and from whatever planet and with whatever instruments, was participating in something that transcends the answer. A gesture toward connection that means something regardless of whether it is received. A signal sent into the dark that matters not because of what it might find, but because of what it says about the kind of mind that sent it. We are the kind of mind that looks up, even knowing what the silence might mean, even knowing where the looking might eventually lead. We look up anyway, and the looking itself is an act of fidelity to the universe that made us, to the question that defines us, to the possibility, however remote, that somewhere in the dark between stars, something is looking back. The silence is vast, but we are the part of it that is not yet silent. And for now, that is everything.